we're going to be adding something to the quiz. It's going to be 1-1 to 1-4. Some of it's just going to be evaluating expressions. Some of it's going to be PEMDAS, just all the things that you did in there, knowing some of the properties, what represents the properties. That list right there tells you. But one of the things you're going to have to do is some stuff like we're going to do for our work today. Okay, so there's two sets of terms you need to know, and one's on page 17 and one's on page 18. If you have one term, like let's say I'm just looking at this right here, what separates terms are pluses and minuses, okay? That's how you know you stopped one term and you've gone to another one. You see an adding sign or a subtraction sign. There's no adding or subtracting in this first term, is there? That's one term because there's no pluses or minuses in it, subtracting and adding. So since it's one term, mono means one, so we call this a monomial. If it's one term, it's a monomial. If you look at the next one, you see this plus sign. That means there's a term here and a term here. Now, when we're telling how many terms they are, bi means two, so that's a binomial. There are other prefixes that mean these things, but these are the ones we use in math. How many terms are in this? Three, yeah, and you knew because here's one, there's a subtraction sign, so that separates it. There's another term, there's an addition sign. Oh, there's three terms, 1, 2, 3. So that's a trinomial. If you think of a bicycle as having two wheels and a tricycle as having three, that can help you remember binomial, trinomial. And then monomial, you might think it might be like a unicycle, eunomial, but it's monomial. Unfortunately, that little memory thing kind of falls down on you. I didn't finish this last one here. I think I was working on that. And then, again, this is straight out of the book. This one has more than three terms, right? See how many? There's like 1, 2, 3, 4, 5. After I get over three terms, I quit worrying about specific names for anything, and we just refer to them as polynomials, okay? You could call a monomial a polynomial, but usually books are more specific than that, and they're trying to give you information when they say, multiply the two monomials. They're just trying to say, hey, I got two terms and I'm multiplying them. So these terms, you're going to need to classify things, and we'll be doing that in some of this work today if we can get to it. Flip over to page 18 in your book. You can write this out of the book later. I would just say see page 17, see page 19, because I'm just pointing this stuff out. We classify things two ways. One of them is how many terms, like we just did. And the other way we classify them is by degree. And you already know some of these words, but you haven't put them together maybe into as a really formal way of looking at it, and this is on page 18. And so if I have what's called a constant, that is degree is 0. That means there's no variable on it. In other words, that's what that means. That would be like a number like 7. We don't see an x there. I could put an x. I could put it as an x to the 0, because an x to the 0 is anything to the 0 power is just 1, isn't it? What would 7 times 1 be then? 7. Lazy mathematician is not going to write x to the 0. It's too much extra strokes that he doesn't want to make. So that's what a constant is. It's just a number. We could put a 0 on the degree, but we just don't do it. We're not used to doing it, and we don't want to get started now. The next thing you've got is called linear. A linear term, the variable has an exponent of 1 on it. I'll just put exp for exponent. So like if I had 5x, or if I had 2x plus 9, the biggest exponent on either one of those expressions is the invisible 1, isn't it? There is an exponent there that the lazy mathematician just doesn't want to write. So it's a degree of 1. The exponent is 1, in other words. When we're talking about the degree, we're talking about the exponent. Y'all, we did a lot of linear equations in Algebra 1. That's what mostly you do. And then after you do linear in Algebra 1, you get into a little bit of this. If I have the biggest exponent is 2, I say the degree is 2. That is called not a bidratic, which you think it might be. It's a quadratic, which doesn't seem to make a whole lot of sense because a lot of times when we think of the word quad, don't we think four, kind of? But you think about your muscles in your body. Where are your quads? Aren't they your upper legs?
Yeah.
They're your upper legs, right? How many of them do you have? You just have two, right? So it kind of, there is a way to kind of remember that quadratic, your quads, you have two quads on, you know, the upper part of your leg. So that would be stuff that would be like 5x squared plus 2x plus 9. If you had all those terms, the thing about it is I don't have to have all the terms. I just have to have one that has that 2 on it. And that's the largest degree that we see. And I'm going fast on this because it's in the book and I want to get to problems. Cubic is degree 3. So as long as I had something that had an exponent of 3 on it, that would be a cubic expression because it has an exponent of 3. Degree 4, if you look in your book, that's called a quartic. Quartic, like a quarter, except with IC on the end instead of ER. So that might be like x to the 4th plus 3x cubed minus 2x squared. It doesn't really matter about all the other stuff. Huh? Yeah, the largest one has to be a 4th. And that's all that matters there. I'm running out of space here, but quintic means you've got a degree of 5. Think about quintuplets. If you ever hear a news story about quintuplets, that means there's 5 babies. Oh my. That's a lot of babies to take care of. And that would mean something that has a largest exponent of 5. And then after that, they don't give them special names after a while. They kind of just stop at quintic. And again, this is on where in your book?
18.
Page 18. So if you can't read it, this is where I'm getting this information. You can always go back because that gets really cluttered. I'm just trying to give you a run through of it. And they even have memory aids in the book on page 18. So I would write down that. Okay, they want us to tell it, is this a polynomial? Polynomials just have exponents on the variables. Okay, it is. It is a polynomial. We'll see some that aren't a polynomial in a minute. And so we're going to classify according to degree and number of terms. And though we would love to say 4th, what do we have to say? Quartic, yes. So it's quartic. And how many terms are there?
I thought quartic 3.
Quartic is 4, right?
Yes.
Quadratic was 2. So there's quadratic and there's quartic. They're very similar, aren't they?
I put quartic as
Okay.
the second degree.
But it's quadratic. Quad, remember the...
I was saying quadratic.
Okay. And how many terms does it have? 3. So that makes it a... 3 terms like a tricycle trinomial. So you'll have a few of these on your quiz tomorrow. Quartic trinomial. You will. Okay, let's talk about things that are not polynomials. 5 is not a polynomial. Let's look at it. 3x squared y minus 57 over x. The fact that we've got a variable in the denominator, anytime you see that happen, that's what we call a rational equation. It's a fraction, isn't it? But normally fractions aren't a problem. But when we start putting variables in the fractions, they actually make graphs that look like this. Okay? If you were to put it on the calculator, you would see it's kind of weird, and you can't even plug x is 0 in there, can you? Because if you did, you'd have an undefined fraction, and the math police would come get you because that's illegal, right? So this is not a polynomial. So are we going to try to name it like a polynomial? Nope. Not a polynomial. That's what that might look like. 2 things that we've seen so far: variable in the denominator, not a polynomial. Variable under a radical, not a polynomial. So that's why I'm pointing these out. What about, let me write one here and y'all tell me. Is number 9 polynomial? No. Why not? Yeah, variable in the bottom. If I plug in x equals 0 there, the world's going to explode. Ask Siri. She'll tell you what. Can't divide by 0, 0 cookies. Yeah, and you divide 0 cookies among 0 friends, you know. So even Siri gets goofy there. Look at 21 because it's kind of weird. 5 squared x 3y 7 and 8 z to the 9th. What do you think that one is?
Double ones, 2 degrees.
Okay, let's this is a weird one, and I've never seen algebra books give you these problems except for this book. First of all, let's clean it up. 5 squared is 25, right?
And then the biggest number is 6 and above.
Was number 9 not a polynomial?
Yeah, not a polynomial because of that x in the denominator messes it up. And you're going to find out in algebra those are the two things that mess things up is variables in the denominator, variables underneath the radical. Things happen we have to watch out for. That's going to be a big theme this year as we study different things. And they're kind of trying to get you to think a little bit about it now without knowing what I just told you. All right, now, the biggest variable I see here is 9, but what do you do when you have something like this? You actually add these two together. So this is actually a 10, right? 3 plus 7 is 10. This is weird. So this is actually a degree 10. You take any term. First, clear up the numbers. We know 5 squared is 25. That's not a variable exponent, right? So we're not going to count that as a variable exponent. But if you've got different variables and they've got exponents on them, you add those together. And since that's 10 and the other one is 9, 10 is bigger than 9, so we would say degree 10. It's really weird. I've not ever seen another Algebra 1. Even the pre-calculus book doesn't talk about this.
If there's a number and it's linear, can it just be x by itself?
Which one are you kind of looking at?
I'm
One?
referencing number 8.
Okay, let's look at number 8. Yeah, let's see. Oh, 8 says square root of x times 5.
Okay, so it's going to be...
Yeah, not a polynomial because it's under, the variable's under the radical. So it's all about the variable. Where's the variable? As long as it's not on the bottom of a fraction or underneath a radical, it's a polynomial. But these are just kind of, we're going to be studying all these types of equations this year, so we're just kind of getting used to thinking about, hey, does this work in a real easy way, or do I have to worry about things that would mess it up?
Would number 8 be monomial or 5?
Oh, actually, that's a good question. It's not a polynomial function. If I were talking about this in terms of how many terms are there, when we multiply, don't we just squish things?
Yeah.
So wouldn't it be 5 square root of x? I knew what you meant, yeah.
Yeah.
So that would be a monomial, you're right. A lot of times if they're not going to, if it's not a polynomial to begin with, they won't even ask you to. Well, actually, it wouldn't be a polynomial. You wouldn't even call it a monomial because of that square root thing. You would just go, don't have to do it.
Would it be